Hi everyone! So far you've learned about the basics of integration, but now we're going to look at some integrals that are a little bit more complicated and the methods we can use to solve them. The first one is the substitution method. Let's go! Okay, so the substitution method is an integration method used for functions that are a result of the chain rule. If we remember the chain rule, that's the derivative rule where we have a function that we find the derivative of, and then we have to multiply by the derivative of that internal function. Okay, so the substitution method is going to solve those types of functions. Let's look at a couple of examples. On example 7, we have find the indefinite integral of 3x squared plus 5x to the power of 4 multiplied by 6x plus 5. In the substitution method, we're going to substitute the expression whose derivative is being multiplied somewhere in the function. In this case, we have the expression 3x squared plus 5x whose derivative is being multiplied right here, 6x plus 5. So we're going to apply the substitution for the expression in pink. So we have u equals 3x squared plus 5x. Okay, that means the differential of u, or the derivative of u, du, is going to be 6x plus 5 dx. And we're going to replace this expression back into the integral. So it's going to look like this. 3x squared plus 5x is what I called u, and this is being raised to the power of 4. And then 6x plus 5 dx is what I'm calling du from the substitution. Now this integral is a power rule that we learned in the previous session. So the antiderivative or indefinite integral is going to be u to the power of 5 over 5 plus an arbitrary constant c. Okay, and now we can go back and replace our variable with the actual expression. So our final solution is going to be 3x squared plus 5x to the power of 5 over 5 plus a constant c. Now you guys can check to see if this expression is correct by finding the derivative. Okay, and for this particular function, when we find the derivative, you're going to have to apply a chain rule. Now let's look at question B. So we have the integral of cube root of x squared minus 3x multiplied by 2x minus 3. So in this case, again, we have the expression x squared minus 3x whose derivative is 2x minus 3. So our u substitution is going to be for that expression underlined in pink. So we can set u equal to x squared minus 3x. And that means the differential of u is going to be 2x minus 3. So we're finding the derivative and then dx. Okay, now we can substitute it into our integral. And now this is also going to be a power rule where we can turn the cube root into an exponent. And then solving. . and now replacing our substitution. Okay, now let's take a look at question C. Question C has a little additional trick that we have to be careful with. So let's have a look. Now we have the integral of x multiplied by e raised to the power of 4x squared plus 1. Now if we pay close attention to this expression, we really can't find any expression whose derivative is directly in the function that's being integrated. So we have to apply a little trick in this case. So we're going to use the substitution u equals 4x squared minus 1 or plus 1. Now let's find the differentials. So we have du is 8x dx. Alright, if we look at the expression for part C, we don't have 8x, but we do have x. Okay, so we can apply a little trick, which is to multiply by 1, but the 1 that we're going to multiply is a very special kind of way of writing 1 that's going to allow us to use the substitution method in this case. So we have the expression x e to the power of 4x squared plus 1 dx. Okay, but we need 8x, not just x, we need 8x. So a simple solution is to multiply by 8x e to the 4x squared plus 1 dx. But if we multiply by 8, then we also have to divide by 8. Okay, notice that 1/8 times 8 is 1. So the expression is not really changing because all we did is add a couple of numbers whose product is 1. So the expression doesn't change, but it does allow me to have the 8x that I need for the differential in the substitution method. So now we can apply the substitution. We're going to have 1/8 outside and we can apply the substitution here. So 8x dx is du and e to the power of 4x squared plus 1 is just e to the power of u. Now the integral for the Euler function here is just the same, so we're gonna have 1/8 e to the power of u plus c, and now we can replace the u with our expression. Don't forget the constant c, always the arbitrary constant. Okay, alright, let's take a look at the last example. Integral of 12x cubed minus 3x squared over 3x to the power of 4 minus x to the power of 3. So again, we have to look for those expressions or that expression whose derivative is also being multiplied in the integral. In this case, if we look at our denominator, we see that this denominator has the derivative in the numerator. So we are going to apply this substitution with the denominator. U equals 3x to the power of 4 minus x cubed. And now we find the differential. and we can replace this expression into our integral now. Okay, and the integral of 1 over u is the natural logarithm of u plus a constant c. And now we can replace our expression again. Okay, so the substitution method can be a little tricky because sometimes it's hard to identify the expression that you should use the substitution with, but it's just a matter of practice. Okay, practice makes perfect. And with a few exercises, I'm sure you guys will be able to get the hang of it quickly. That's it for this video. See you next time.